Chapter 1. 500 years ago, something started to take shape. When Gutenberg published the letterpress, distribution of written language took over like a wildfire. This allowed for people to read more and more and become intellectuals. The written language formed the way how knowledge work is done and how the knowledge workplace looks like. But ask yourself, who decided how knowledge work is done? Who decided the workplace? Interaction designer Brett Victor, who worked at Apple, has an interesting opinion. He states the following: to sit at the desk and stare at your tiny little rectangle and make little motions with your hand, this is what it means to do knowledge work nowadays. This is what it means to be a thinker. This is basically just an accident of history. This is the way how our media technology happened to evolve, and we designed a kind of knowledge work for that media that we happen to have. So it seems like the whole media evolution seems to have an effect on us, and it's frightening me. What I feel is that by not steering technology into the direction that fits us, it enslaves us. There are 3 researchers from neuroscience and psychology who dedicated their life works towards trying to understand how people think. Each of them has come up with a different spectrum how the languages of thought take shape. Howard Gardner categorized our ways of thinking as visual, verbal, logical, musical, bodily, intrapersonal, and natural. Jerome Bruner categorized our ways of thinking as the inactive, the iconic, and the symbolic way. And finally, Kieran Egan categorized our ways of thinking as somatic, mythic, romantic, philosophic, and ironic. All of us sitting here carry these languages in us. They are part of what makes us human. Ludwig Wittgenstein clinically laid out the things we can talk about. He talks about the border of our thinking, the point at which many important things transcend the capabilities of language. So my question is, why do we favor symbolic and visual thinking over every other way of thought? Why does intellectual work in the form of research publications and science formalities completely prioritize this reduction when its human spectrum of thought is much broader? Don't you think that we're missing out on the fundamental understanding how we can utilize our potential to think in different ways? If you look at this kid here who is calculating math with his fingers, he's using a very efficient way that would not be possible with pen and paper. He's using kinesthetic and tactile thinking to solve a math problem. Technology is drenching into every section of our lives, and we cannot happen to be heavily influenced by it. So when I started out in November last year, some of my first ideas led to the approach of trying to enable free gesture interaction for using computers. I assumed it might be possible to improve the way we interact with technology. I bought a device called Leap Motion that tracks your hands with infrared sensors and AI technology. It creates a skeleton reduction of your hand, and you can program movements into it. Some of the experiments allowed for an alternative way to use the operating system, for example. My recordings here might look fun, and also for the first minute or so it seems like a cool approach for a workspace modification. Any gesture demo I created or tried out failed to make the system better. It always made it worse. My arm would always go tired. The only interesting resting point was with an arm rest of the elbow and using wrist gestures only. Closer observation to the keyboard and mouse also show you these are gestures we are using to interact with the system. Just very, very subtle ones. And I asked myself, why are they so subtle? Interestingly, digital knowledge work is super physically minimalized. And to understand this, mental and physical efforts are both energy consuming. Oversimplified, for survival purposes, we always judge an action on its outcome before we do it to save energy. And we always judge a task by the length it takes to complete. With the advance of technology, the amount of energy it saved to achieve something has continuously went down. When Tom Cruise in the Minority Report movie does a gesture interaction performance to browse through a video clip, he's physically all over the place. But as long as we don't make a system interaction less energy intensive, it's also not going to be more efficient. So movie concepts usually aren't going to happen. I concluded, if the potential of hand gesturing should be utilized, it probably has to happen spatially. And if it happens spatially, it's required to meet equal efficiency standards of the existing system. In 1957, filmmaker Morton Heilig invented a large booth-like machine called the Sensorama. And the first actual virtual reality head-mounted display was created in 1968 by computer scientist Ivan Sutherland. These inventions arrived years before the first graphical user interface, but were too computationally heavy to take it any further. Here are the languages of thought one can utilize for an augmented reality system. Augmented reality means you have a 3D holographic overlay on reality. So you can see your real surrounding while having an integrated digital interface. So now what you can see here is a prototype of the Magic Leap, an augmented reality head-mounted display that arrived on the US market late 2018. The glasses feature a transparent display, which gets the light waves through a bouncing effect from the sides. This patented approach is necessary to enable display transparency. When reaching the intended position, the light waves project directly on your retina and increase your perception of illumination of certain areas. By having different depth projections, three-dimensional spatial holographic imagery can be displayed. So when the research phase of this diploma took turns towards spatial computing, I became a bit nervous because in order to gain practical experiences meant spending a huge amount of savings to order this prototypical device for $3,000. So I was turned off by the idea. Another risk was that this technology is not some front-end web technology which I used in the last 10 years. It's a mix of Unity and the C# programming language, Lumen SDK based on PHP, and requires cloud connection to Google Cloud services and databases. The documentation of working with the device is largely undocumented. There are online archives of raw code dumps. You can take the pieces and see if anything works and then figure out what to make from it. There's no video tutorial of some friendly person explaining to you step by step how you can do this or that. I've never before worked with Unity, never before written anything in C#, hand gesture tracking, meshing and scanning technologies, object recognition AI, eye tracking functionalities, head pose tracking, and don't know anything about Lumen or working with AR remote servers and such stuff. I was very motivated to dive into this topic practically, but realized there was no chance to make it happen without a partner. So I asked friends who I worked with in the past and discussed. I've worked very well with Elias, a colleague from previous projects, and he was enthralled by the idea. Much like me, he was also in a personal phase where he had the time to research on a non-commercial project. So we decided how we divide responsibility, where I took part of the more designy area and Elias took part of the more technical area, but we ended up having a healthy overlap as a team, where I participate in the coding and he assists in the product thought process. in this presentation, if I talk of we, I mean Elias and me. So I ordered this Magic Leap thing via my cousin in the United States, and it arrived some weeks later. It was quite the hassle to get it, but we managed to. A polished, perfectly elegant, retro-looking augmented reality headset. What you can see here is a lie. This is a prototype state tool, only accessible for hackers and developers. It's a complete waste of money as a consumer product despite its looks. Instruction originates from the French and is the act of or process of teaching. Instructing is one of the most fundamental practices in human communication. And we've invented many different ways of instructing through media. Some of these inventions are written language, spoken language, books, music, photography, videos. We use media to instruct scalably to many people. We require media to instruct in certain ways. And a new medium to instruct could be an augmented reality medium. So in communications design, you always have a sender, a medium, and a receiver. And the sender imports his message and knowledge to his medium of choice. And the receiver then accesses this message through the medium. Now, since augmented reality headsets have the ability to speak in at least 5 languages of thought, my idea was to create an instruction assistant. A new media format to be constantly improved with really functional attributes to import knowledge and access knowledge. So what could such an instruction be? I often do home cooking, but I hate the way I have to learn a recipe. There's no help seeing a perfect cheesecake image in a cookbook. Recipes are so bad, you have to read them completely for multiple times to understand the process. And when you want to read what you have to do, in parallel, you have to go down with your eyes and look for the ingredient numbers. And when you go back with your eyes, you have to find the point where you've stopped reading. When you read about complicated activities, like how to skin a raccoon from back legs to hooks, your mind isn't capable of imagining what exactly you should do, because it requires inactive and iconographic language, not plain symbolic representation. When you watch a cooking video, you have to move to the comments section to read the ingredient number. And when you want to review a specific step, you have to navigate in the progress bar by guessing. Just to understand the process, you have to watch the whole thing once. This is really bad from a communication design perspective. Most instructions on this planet, much like the cooking recipe, are just bad products. Mechanics don't read 300-page paper manuals when they have to fix a machine. You don't go through the whole library of a software before starting your first click. I firmly believe instructions are broken, yet unless nobody makes something better, there is no reason to whine about it. Saul Verman, founder of the TED conference, coined the idea of Verman's law, which states that information can only be categorized in 5 ways: location, alphabet, time, category, and hierarchy. These information design principles have a lot to do why recipes have friction as an instruction medium for cooking. So let's start somewhere. Doing home cooking, I imagined how an instruction assistant would look like, so I created a demo video. This is a possible interface for my augmented reality headset. You see a fixed 2-dimensional interface. It features some context-sensitive understanding with recognizing a pot, for example. It recognizes ingredients and checks them automatically. There are timers and alerts that prevent mistakes. Just waiting for the alert. There we go. Stir the noodles before they burn. Okay. The first interface in mind was based on a mix of the ideas of free gesture interaction and a fixed 2D instruction display that told you all the necessary information for each step, and you could go back and forward with your gestures. One of the more developed screens featured a color coding system and overall progress information display, additional video informations for each step, and navigational menu. The color coding system comes from programming, where color classes help read and identify code more easily. The assumption was it might improve mental effort of decrypting symbolic information over time. When starting to create the instruction for the augmented reality device, I noticed the process of adding instructions into the device requires a specific order of information. When Elias and me created the first prototype how to operate a coffee machine, we also noticed there can be things like decision trees that require for more complex process visualizations or process creation flows. So we designed a flow-based creating tool that allows to create and edit step-by-step and inspired ourselves by flowchart tools. Newer versions of this flow-based editing tool should allow to drag and drop steps, create branches, add interactive media, and link to specific points in the room when the instruction step is about guiding. With this, we are setting the foundation for how physical processes can be stored in the augmented reality medium. So here it finally is. Here I am recording a video of our first prototype. The instruction we chose is how to make a coffee with a Senseo coffee machine. All step navigation can be done with 3 midair gestures, and we chose the ring sign and the L sign, the loser sign, as these were some available from the small palette of readily working gestures, so we didn't have to program our own gesture identification technologies. We noticed that any display should keep horizontal even when the head rotates sideways. And we got rid of the shaking by creating a smoothing pass of the following interface. And we enabled gestures for both hands because in our numerous user tests, we saw people using the other hand when one was occupied. What seems naturally wasn't natural before we observed it. With Saskia's beautiful diploma today, you've already learned something about how memorization works. In 1969, Edgar Dale did a study and found that 10% of what people read, they actually remember as long-term memorization. For direct purposeful experience, this number was 90%. Literally, anything could be remembered if taught in the right technique. I am testing our instruction application by cooking on a weekly basis and trying to figure out how memorizable it actually is. One of my fears is that all of this could actually lead to de-skilling rather than to better learning. We have to be very careful with what we do and understand how to design in a productive way rather than creating a system where the negative side effects outweigh the positive ones. Now, after learning and improving the prototype, here you can see a cooking documentation. I loaded a really complicated recipe on the glasses and made sure I had the ingredients. The rest is unknown, so I had no idea about the outcome. I've observed while working physically that my head rarely goes up, so I figured it would be a great place for information to be accessed. The interface moves with me while I walk around, and it's programmed to be above the working line. So the working line is around here, and then the interface in this area, and you work below. This prevents overlap of informational and working area. Sometimes you see me doing a lot of gestures at once, like now. That's because the system falsely identifies gestures while molding dough and activities like these. So we continuously have to find ways how to get rid of that. Digital amnesia was defined when learning that people remember information less when they believe it's available online. At the moment, we don't have relevant results for what we're doing, but it's important to keep the observation up to prevent creating a system that dumbs down its users and creates dependencies rather than liberation. It could be that the moment one knows to have all information available in the classes, he then won't care to remember them anymore. Some weeks into cooking confidently with the prototype, we asked ourselves whether a home cooking application for wealthy customers and consumers would be the right way to demonstrate the idea. Luckily, we had the chance to find an open ear to a colleague who works in a biology cancer research laboratory and pursued the company to spend some time with us and brainstorm about what can be done. So we worked together to produce a demo for doing a lab protocol and organized a day at the lab for testing. The initial use case is set for DNA extraction and has 58 steps. So what you can see here is the two-dimensional fixed interface at the top of the viewport, and as before, we're fixing this above the working area. The immediate instruction step is the most central element, dominant in size and most easy to read. Then there is the section title to hint in which process area you're currently at. And there's a number indicator that tells you the step in the subsection. And then there's a progress bar in the middle that serves as an optical divider and gives optical stability, but also shows the total step progress. The interface is rudimentary. The design prioritizes usability over styling. So let's have a look how it works. This is Irene, a biotech lab researcher. She's doing pancreatic cancer research and usually performs her research in the laboratory by doing protocols. Right now, she's doing a new protocol for DNA extraction. See these glasses on her head? She's using an augmented reality device with a built-in software assistant to help her do the protocol. Wearing gloves in a sterile lab environment, she uses free mid-air gestures to control the assistant. The instructive step-by-step interface helps her keep track of the task and focus on the activity. In biotech research, many protocols are complicated and non-repetitive, therefore require clear instructions as a preparation. When doing the research on the computer, Irene and her colleagues can create and modify protocols and send them to their augmented reality glasses. Experienced experts like Irene often have to onboard and train new employees. They introduce them to unique workflows and teach them the lab rules. This repetitive task can take weeks if not months. With the use of the augmented reality software, senior researchers now store knowledge in onboarding lessons. Knowledge how to use machines and instruments is saved, which can then be used infinitely by new trainee co-workers to learn on their own. When a protocol is finished, the augmented reality assistant can send the results and finalization notice directly to who's in charge, not only keeping track digitally of what has been done, but also reducing communication times between interdependent colleagues. Digitizing activity and results allows Irene and her team help increase intra- and inter-laboratory reproducibility of experimental findings. What we've discovered here is a potential need of a profession. With this concept, we've only just made a first step into the universe how lab research is done. We provided a working instructional system based on text. This is just a fraction of the possibilities of how this new medium has to be. We do, however, have to take it step by step and learn by doing. We also ran into large problems, like when trying to enable indoor navigation, to do Google Maps for walking in your environment. The idea is to allow the usage of indoor mini-maps you can open with your hand for orientation, like this. Like you can see in our demo video here, which is one of the concepts. At this point, I concluded what I've been doing for my project are actually two things. First of all, I'm openly trying to create something that has the value of a good tool to a worker. Secondly, I'm being confronted on a technical and design level where knowledge is created through the practical process. These experiences would be very useful if they happen to be shared. There are many entertainment applications in virtual and augmented reality, no doubt, but they follow other rules. Designing productivity use cases are the hardest by far. They have to better challenge existing systems, like you can see here, like pen and paper or tablets or personal teaching. To share our knowledge, we created a publicly available website. I've documented the most interesting parts of our 6 months process and wrote articles parallel to the research and practice phase. The publication is a documented framework for creators, designers, and experts around the world. It serves as a design manifesto for augmented reality design. The posts are intended to be factual and objective, and also critical towards all the observed negative effects of AR. With these continuous publications, I try to take public responsibility as a designer to influence others in their thoroughness of their decision making. The way I designed the appearance of the blog was to look like a research publication. Because even though we're not conducting large studies, our process tries to find the most truthful answer. The Simplon typeface, which is a Dean clone, is a readable and narrow font which has great attributes to display instruction text in the AR app, and still kind of keeps its slight industrial touch from the origin of being a typeface that could be hand-drawn with a paintbrush for signs. The content is neatly organized like a folder system where elements are not battling each other for attention. An intensive use of call to actions would kill the environment. The appearance is mostly monochrome to not overstimulate the senses and seeks for a reductive simplicity with its illustrations. The appearance of the illustrations are much the same as the writing style, which gets its beauty from its clarity and simplicity. The background, which is hard to see on a beamer, has a very subtle light beige tone to reduce the contrast and increase reading comfortability. Some of the topics discussed are the rectangle, human capabilities, comparing AR and VR from different viewpoints, information design and substitutive reality. It's hard to touch here, so you have to read it. You can have a look at the framework in the exhibition. It's also live on blog.octa.io. Throughout the times, people have always shaped themselves by shaping their tools around their capabilities. For our further generations, it's going to be inevitable to not perform knowledge work to some degree. So I want to live in a world where technology is designed by human capabilities and not the other way around. Thank you.